Yo, welcome back. Well, this is your boy YK Wiki Panda International, the world's most effective atomic what effect. Now, it has been really a long time without me producing content, but we are back. Yeah, we are back. So, today I want us to look at the introduction to programming, and as you see, we have computer, we have computer programming. So, with computer programming, these are two words. First of all, you have to understand what a computer is. Understand what a computer is before you understand the what? The programming. So basically, you've been seeing a lot of things, and then the apps that you use on your phone, the website applications, if you're a student, the ERP that you've been accessing, those are all made through programming, computer programming. So you have to understand what a computer is. So, what do we understand with the term computer? So, a computer, number one, a computer is an electronic device that is going to process that data into the meaningful what information. So, it is going to process through you inputting, and after inputting using a keyboard, it has to process using a processor, and then that is from the CPU. It gives us the output, what you see on the screen and stuff like that. So a computer inputs, and then it processes, and after doing the processing, it gives us the output. So a computer does not understand the English, the normal English that we speak, the way we communicate, the grammar, and stuff like that. So computers understand binary. You know what I'm saying? Computers understand binary. So with binary, this is zeros and ones. That's all. Yeah, that is it. Zeros and ones. So remember, with binary, that is base 2, and that is why we have the 0 and ones. So simply meaning, because the 0 might mean off, and then the 1 on. That is it. So now we have to understand this. But remember, binary, this is a number system. So exploring number systems, so you have to understand really how computers communicate. So the first number system, we have the decimal, that is the base 10, and this is our everyday system. So we use digits from 0, 9, and each position represents a power of 10. So with binary, this is the native language of computers. This is the zeros and ones. You understand? So this is where the dictology comes in, but we shall see that in our later videos. Okay, we have the octal, that is base 8, and we have the hexadecimal. You will see that when it comes to like the memory referencing, and then the networking. In networking, where we have the IP version 6. Yep. So we shall see that in networking, and then back to our binary system. So now, example, to a computer, this is how it's going to see the 13. So the 13 is 1, 1, 0, 1. That is basically how a computer sees the number 13. So that is how we come up with a binary. So you understand, you divide the 13, you have to divide, you divide the 13, and then we take the remainder, and then we have the 6, we divide still by 2, and then we take the remainder, we divide the 3, we take the remainder, we divide the 1, we take the remainder, and then we do this from down to up, and this is why we have this. So this is how a computer is going to understand that this is your number 13. So the decimal system, this is the decimal number system. This is our base 10. You understand? This is what we use in our everyday. So the example is we have our 345. This is 345. So this is how we do really small. So it takes a position. Now, for example, hour. This is a 1, then this is 10, and then this is 100. So with this, we multiply the 3 and multiply the 3 times 100 plus the 4 times 10 plus the 5 times 1. This is 300 plus 40 plus 5. This is how we came up with 3. This is the normal decimal number system. So with the decimal number system, this is basically base 16, and we shall see this. I'll explain this deeply in our coming series, where I'll have to talk about a lot about hexadecimal. So now we have to understand what programming is. Now programming, this is just an art. For example, it is an art, and at the same time it is a science, you understand, of instructing computers to perform specific tasks. Now basically this happens. Now for example, if you have an idea and then there's a problem and you want to solve this, you understand. So remember, most of the time we are solving problems when it comes to programming. So there's a problem that is around the community, and then you want to solve it. You have an idea, maybe it's a video game, you have an idea, you understand. So we come up with a problem solving, and then we identify the challenge, the tasks that are in that need the automation, and then stuff like that, in case we are going to add in the automation thing. And then we come up with the logic and the algorithms. This is where we come up with a step-by-step solution. Now with a step-by-step solution, it happens with different tools. Now we can use the pseudo code, we can use the flowchart. So now the pseudo code interprets the step by step, but in a plain language, so in a language that humans understand. So you write the pseudo, like odd number and stuff like that, and then we have the flowchart. So the flowchart is a pictorial representation of our algorithm, the step-by-step solution, you understand, before we go into the writing of the code. Now the writing of the code is where we translate algorithms into the programming language. So we have different types of programming languages. With the different types of programming languages, we have the high level, we have the low level. So now the high level is close to human understanding, whereas the other low level is basically close to machine code, machine to a machine understanding. You understand? Yep. Okay, so we write the code using the high level. So examples of programming languages in the high level, we have Python, we have C++, we have Java. So when we write that, after writing that, we have to do the execution. So here we oh here we go. So now the programming journey from an idea to a solution. We have an idea, then we have an algorithm. This is a step by step, step by step. And then we have the pictorial representation. This is where we have this, and then we have this. And this has the start. We have to represent the inputs, then the outputs, and then we end the program stop. We are going to see all this, and then we come up with the code, and then the code. This is where we'll see the PL, the programming languages, and to the solution that we need. So programming languages, as we said, now programming languages, the different types of programming languages, as we say, the high level and the low level, but we also have examples of each. So the high level we have Python, we have C++, and then for the low level we have the assembly. So now a programming language is just a structured set of rules, you understand. It enables humans to write instructions for a computer to understand. So with this comes up, for example, let me give you we have an idea, you have an idea. So you want to add two numbers and display the results. So we need a programming language. Because it has to translate the idea into code. And then we have to use a programming language, for example, like Python. And then print the results. So execute. As we said, types of programming languages, we have a high level, and then those are close to human language. For example, we have Python, C++, for low level, close to machines, we have the assembly. So now let me just explain how this works. So before doing anything, remember you have an idea. So after having an idea, there's a magic box. So now where is the magic box? So now you're going to use the high level language, for example, that is C++ and Python or any of your choice. Now you choose C++. So now with C++, there's a compiler and a linker. This is where the magic box is. So now our magic box has a compiler and a linker. So now the compiler reads, analyzes, and translates the code into an object file. So now after translating the code into an object file, we have a linker that combines one or more object files with necessary library files to create a final executable, that is that .ex file, and then it is converted into a machine code, and then this executable file contains binary instructions that computer processor can directly understand and execute to bring your program to life. So before we go into that, choose a programming language, you need what we call an IDE. So what is an IDE? So an IDE is an integrated development environment. It's a software application that provides programmer with a complete suite of tools for writing, testing, and debugging code, all in one place. You understand? So think of an IDE as a fully equipped workbench for programmers. So instead of looking out for different separate things. So now you can, if you don't have an IDE, this calls for you having a compiler, and then you use a debugger as a standalone and stuff like that. That is too hectic. Yep. So you need an IDE. Now examples of IDEs, we have um, Visual Studio, we have Notepad++, we have Sublime Text. There are a lot of IDEs. Depends on what you want, and then what makes you feel okay and stuff like that. So it is what it is. This is your boy YK Wiki Panda International.